we talk about what is a quantum computer and what is it for, why we need a quantum computer. The primary interest of quantum computer is hacking the encryption key used for internet secure communication. I have other videos that explain how the secure communication is done. It's basically done by the large prime numbers, and the hacking that key using a general purpose computer takes probably many years. So that's the way it's secured, but it can be done, right? Okay, the quantum computer is a specialized computer that can hack those keys, and that's not only one purpose. That was a primary interest, and that's why CIAs and all NSAs are investing money on this. The other application, like chemistry and others, were proposed recently. Well, it's computer, so it can be done. It can do anything? No, it's not. It's a specialized computer. It can solve only some special problem, like hacking encryption key. Okay, so quantum computer usage is somewhat limited. Now, let's look at how the encryption key is generated in the secured communication in the internet. Okay, encryption algorithm usually use large prime numbers. Prime number is like 2, 3, 5, 7, 11, 17, so on. So the number that you cannot divide. The reason is, okay, why encryption use prime number? The user mode is a programming language. It's basically remainders of the division. After you divide, whatever the remainder is, that is obtained by the mode function in the programming. Okay, so mode generate quite random number. Okay, that's the way artificial random number is created. But in order to do that, we have to use very large prime number, because the small prime number, anybody can try it out and guess and break the code. In order to avoid being hacked, they use a large prime number. Okay, so encryption key, the data is encrypted and become a series of mode, random number, remainder of many number. Okay, so encrypted data is sent out as a secured data, but receiver bring it back original data by using a key, and that key is made of two large prime number, the product of two prime number. The reason is, if they use only one prime number, then it can be guessed. You know, there's somebody may guess which prime number, try it out many prime number, and hack the key. If they use multiplication of two large prime number, then combination is millions of combination. So it's almost impossible to guess. And in order to test out every possible combination using computer, it's going to take many years. So cracking P and Q from the series mode, that means encrypted data. Suppose you copy someone's encrypted data and try to crack it, the P and Q, and that's not possible within short time. Okay, but you know, great mathematician Euler, he found out 1970, long time ago. Okay, there is the mode sequence to repeat itself there is a period of that repeating pattern. And if prime number p and q is large, the period is very long. Okay, but at least he found out that the period is a factor of p minus 1 times q minus 1. Okay, what's good about this finding? Well, if you look at the encrypted data, which is a sequence of mode, okay, and figure out the period, at least this period, using period, we can guess p minus 1 and q minus 1, and by searching through the general computer, we can guess p and q. Okay, the problem is how do you finding period of the large prime number takes forever. It's, the mode is a divide operation, and divide operation is the slowest operation in the general purpose computer, so it's not that easy. But breakthrough came when the mathematician, I think Shor, okay, use quantum Fourier transform. Quantum Fourier transform means it's analyze of the frequency of data, like mode sequence, the encrypted data sequence, and you can analyze the frequency. And there are many possible frequency, and if we use entangled quantum bit characteristic, okay, then some repeated frequencies cancelled out, and only the one we are interested in shows up. This was a mathematician's victory. They came up with this algorithm. So that means if we have entangled quantum bit, then we can use that to find out this period. Once we know the period, p minus 1 and q minus 1, we can guess by simple search. Okay, so we can hack the key for encryption. So as I said, the motivation is to crack the key. Okay, and that's why everybody talking about and investing on quantum computer. But there is a quantum encryption coming up, the new technology, and that's gonna block this quantum computer's attempt. So it's like the chasing game. Even the quantum computers completed, probably quantum encryption is going to come in and protect the data again. And so it's like, which go first. I think the quantum encryption is already available. I think it's some Chinese scientists commercialize it. So once this spread, then quantum computer will be useless for hacking the key. Okay, so that's a situation I'd like you to know. Okay, but the quantum computer, the mathematician found out not just hacking the code. There are other things we can do, and each application mathematician need to develop the math algorithm, and this is quite a job. But by using that math and quantum bits, entangled quantum bits, there are many other applications they can use, like chemistry and other searching problem. Generally talking about the many cases existing, you have to search the exact right one, and that kind of algorithm is useful. So quantum computer is not a replacement of the general purpose computer. It's specialized computer, and what you can do with it, we haven't sufficiently explored yet. We have to wait until mathematicians come up with all the new fancy things we can do with it. Okay, but it started with hacking the encryption code for internet communication. That's what quantum computer is about. Everybody's talking about quantum computer, but are they successful? Well, in order to be successful, you need to handle the large prime number. So you have to have large number of bits entangled together. Say we need at least 128 bits entangled, and that's the hardest part. The physicists are working on it, and they can't do it. Intel claim they can entangle up to like about 50, but not beyond that. And they try to expand this because the number of bits you can entangle is going to give you the large number of prime number. Otherwise, it doesn't have much advantage of using quantum computers. General purpose computer can do if prime number is small, and encryption is done by large prime number. So it's still a long way to go. So the future of quantum computer is still not clear whether we can make it or not. We can ever entangle like 128 bits or not stably and use it as a computer or not, we don't know. Even that, by the time it's finished, probably the new encryption scheme comes into the internet secured communication. That means quantum computer cannot break it. One of secured communication method is use quantum communication, and quantum communication is not hackable. Physically it's not hackable. And I have another video, please check it out. It explains why quantum communication you cannot hack it. Physically it's impossible. Okay, so I hope you enjoy listening, and please check out the video. Thank you for listening.